We'll start class. I confuse myself more. I can really empathize with people who are taking several classes and for whom it sometimes gets confusing because, I teach a variety of different languages, platforms, etc. And honestly, some days I have to look at the calendar to see what day it is to see which language I need to know that day. At any rate, we're going to look at some things in the Contoso University application, both things that were originally in the example and a new thing that I added on. And let's start by looking at the student list, right? We're going to look at a couple things about the student list. First of all, in college, only 3 students. If we type in something, it'll match regardless if it's at the first name or the last name. So if I were to type in, for example, ER, and do a search. It matches both Alexander, Meredith is the last name. So let's take a look at that first, or we can go back to the full list and get rid of the filtering on it. So we're going to look at that first. Second, we're going to look at details page for students, because the students have a list of their classes and grades. Then we're going to look at some things that we have associated with courses, namely a roster page that I added, and then a roster page doing a second version. So we'll try to get through all these today. If we don't, you can study them on your own. I will, and I'll look at possibly including them next week in my lecture. Now, the one thing I want to illustrate, though, is functionality. All right. What I attempted to do by putting in these rosters is I've attempted to come up with something that would be useful were this an actual application. So to have the ability to look up a student schedule, their details, see the student information, and see all their enrollments. That's something that's useful. If you simply go in and scaffold some CRUD pages, create, retrieve, update, and delete pages, and you say that's your web application, you're not really adding any value. It's a file keeping application then, because all you can do is add rows to the database, update them, delete, and so on. The value in IT really comes from when we can combine stuff together. So for example, on this page, we've combined the students with the courses that they've taken. That gives us more meaningful information than if, say, this was not there and it just showed me information about the student. Likewise, being able to search for students. If you could imagine in an actual class, this could likely be very long. All right, there could be more than 3 students, I would assume, at a college. And so there would probably be a couple ways to query a student, maybe by their student number or maybe by part of their name. So when you're doing your project, think of not just creating tables and creating ways to add stuff to them, edit, update, delete, list them, but think of ways that would make what you're creating, your website, useful to a person that was actually using it. And again, oftentimes that comes in the ability to filter data, so to be able to search for specific values. It comes in terms of combining data from one thing and another, to see an order and to see all the, to see a customer and to see all the orders they've placed, for example, or to look at an order and see all the line items that were on that order. All those things are things that make the application useful. So filtering, sorting, combining, these are all examples of ways that you can take that raw data and transform it into information. We don't simply want your applications to be dealing with raw data, taking data, put it in a table, be able to retrieve it. We want somehow to add value to that. So consider that when you're creating your applications, to add value to this and implement some functionality that would actually benefit a user. So let's start out by looking at the list for students. And as we mentioned, there's a link to get back to the full, and there is the ability to search, and the search will find whether it be in the first or last name. All right. The index is pretty straightforward. It's not going to look that much different than the Razor page about it. It's not going to look that much different than any other thing that we've looked at. They have added some things for pagination. In other words, if there's a next page for students or a previous page for students, we're not going to concern ourselves with that today. But it's pulling from the model the last name, first name, enrollment date of the student. The model, however, does filtering on the student. Now, it looks to me like this is some code that was not completely implemented, but we can take a look at it anyhow, even though it wasn't completely implemented. This is defining the set order or the sort order. Equal, if it's empty, then use name description. For date sort, it's looking to see if the sort order equals date. Otherwise, use date description or date. This might be new to some of you. What does a question mark mean in C#? In this case, it is a conditional operator. If this is true, return the word valid, otherwise we're going to return lie. So in this case, if this is null or empty, sort order is null or empty, we're taking name description, otherwise we're leaving it blank. Date sort order is looking to see if the sort order is equal to date, and if it is, date description, otherwise date. If search string is null, then page index is 1. Otherwise, the search string equals a current filter. Current filter equals search string. What do we mean by that? If you look at the query string, see what's meant by that. So I type in and I'm searching for ER. Search string equals ER. So that is the query string. So if its search string is equal to null, then the page index is set to 1. Otherwise, the search string is the current filter. Search string is a parameter. That gets passed in. And that would be the parameter on the query string. So we're creating a list of students to start out. And so we're pulling from context students. That means all the databases in this context, all the students in the database rather, or all the student classes or objects in the entity for students. We're pulling that list from context students and we're selecting everything. This is an example of the query syntax for this. So that populates, when we're done here, we're going to have a list of all students. What order is that list? We don't know. All right. A database is just going to give us a list of all the students. Now, if it's null or empty, it's not null or empty. It's not. We're going to put a where in there to say filter that list to give us a new list where we're filtering what's in that list from before to filter only the things where the last name contains a search string or the first middle name contains the search string. And this looks to me like something that was attempted but not finished. Sort order is always going to be named desk because there's nothing on the query string for sort order. I haven't seen how to put that on there. Let me try this. Or I put my foot in my mouth. We can sort. That's how you get. Again, there are not just 3 students, there are multiple pages. So when we click that, that puts on the query string the sort order, to sort it by date. Otherwise, it puts nothing on the query string, or it puts name desk on there. So that's how that value got populated. My mistake. I thought that was code that wasn't implemented. Then I realized the old clicking the column name trick. So we're setting the sort order here one of those 2 ways. Either descending or ascending. Look at this closer. Click on enrollment date. It says sort order equals date. Click on it again. It says date descending. So that's how we decide whether to sort ascending or descending. So it's either sort by name descending, date descending, or name. And finally, when we're done, we take and we paginate it. We get a paginated list of this, and the page size is defined as 4, which I believe will actually give us 1 less than that, because if I look at this, there's only 3 items per page, and we can page through. There's absolutely nothing in the search string. We set the page to 1. And when we click on those buttons, put up there the page index that we want. So it pulls from that paginated list page index that we want. If there's no value for that, it uses page 1. And then there's the page size. A lot to unpack here. I kind of went about it maybe in a slightly unorganized fashion. Let me cover the 3 things this page does. First thing it does is it does a selection. That is accomplished by this code. The search string will be populated if you're doing a selection. It will then add where clause to that list of students. This list of students is going through a process. Starts out with everything. It then narrows it down by the search string to only give people whose names match. It then will sort based on one of these criteria, which come across also on the query string, and set the value for sorting. And then finally, it retrieves the actual list from that collection. It's going to be a paginated list so that we can do the paging through it. I would think in your projects you don't really need the pagination, but the ability to sort different way and the ability to search is very useful. Study this example, see if you can follow through the selection, the source, and the and sorting, and you can pretty much ignore the pagination. Now, we're going to see a lot of things like this as we go through Linq examples. We're going to create a list, some kind of list. It's going to equal something from our context. In this case, students. We're then going to do a bunch of things to that list. What are the things that we can do? We can filter using the where. We can sort that list using the order by, and so on. This example actually combines the 2 approaches of the query syntax and the method syntax here. We're calling on that list the where method, and we put the condition in the argument for the where method. It also does it with the order by and order by descending. So we start with that list, we apply things to it to transform that list to get what it is that we want. And then in this case, we create a paginated list from that so that we can page through them and retrieve the particular page that we want. All right, let's take a look at then student details. Click on student details. We see not just the student, but the list of courses that they're taking. Let's review the model first of all. Models define that the student has a collection of enrollments. And what's an enrollment? An enrollment is sort of the intersecting entity between student and courses. Because it has, in addition to its own primary key, it has a course ID and a student ID as a foreign key. And we also have associated with it the grade. And then it has the course that is associated with this enrollment and the student that's associated with this enrollment. Remember, this is an implementation of a many-to-many. This stuff is what's actually in the database. But the way this is set up, the model contains pointers and contains the actual objects that these pointers point to. So let's look at details for student. Model to start. This uses exclusively the syntax or the method syntax. All right, just like before, we're getting a list of students. We're then going to transform that list. Include means that we want to populate that student's list of enrollments. So if we just pull the students, we're just going to get the basic stuff in the student model. However, we don't want just the stuff in the student model. We want to see their enrollments too. So we're saying, by the way, also include the enrollments for that student. So it will populate this list of enrollments for that student. With a list of these enrollment objects. And we take it one step further and we say, then include course. When you see include, it's related to the main entity here, main table or entity here. When we see then include, it's related to the one immediately above it. So, in other words, we want to populate everything in the student, including the enrollments. And for those enrollments, we want to populate the course information. So our list of students contains the list of students, the list of all enrollments for those students, for each enrollment, the course that belongs to it. If you've set up the entities and relationships correctly, you don't have to write any code that does a selection or a join or anything like that that you might have done in database terms. Finally, we don't want all of these. We just want one where the ID matches the ID on the query string. We look back at this. When we select a student from the list, that link is created with the student's ID. So when that edit page or details page gets called, that details page gets called and it gets passed the ID. So we click on details for this student. The ID is 2. This is what tells it, hey, I don't want every student, give me the first, and there will be only one since this is the primary key that matches where the ID equals the ID of the query string. So we're building a list, and we're building that list by including related data, by sorting it, or by filtering it. Now, could we have done this another way? Yes, we could have used a where method to do that, but they chose not to. If no student is returned, then that was somehow an invalid student. That would happen if I manually typed in URL. If I typed in 200, it's going to go and do that, try to pull up student number 200. There isn't one. And it gives us an error. It's not found. But if we request a specific one that does exist, it will give us that. So this gives us one, because we said give us first or default. This gives us not a list of students like we did in the other example, but a single student. But that single student has all their enrollments listed as part of the student entity, as part of the student object. And each of those enrollments has all the course information filled in. We don't need to bother filling in all the student information of the enrollments because we already have the student information. That would kind of be redundant. All right, let's look then at the page. The page pretty much looks the same. We display the name for a column, then we display the column itself. Finally, here, we loop through for each item in the models. That's what model means. It means that this variable exists in the model. Student variable. What is the student variable? Well, that's the student object that we pulled using this query. And we want specifically for all of the enrollments. And those enrollments did get populated because when we retrieved it, we did the include. Without that include, this wouldn't work. Let me just, for the heck of it, do this. Let's see if this does what I would expect it to. It blows up because we didn't include it as part of the query. There is no enrollment information in the student. So just because we've defined it in the model doesn't mean we automatically get it. When we specify the query, we have to specify that we want to include it. And that only makes sense, right? The more that you add to a database query, the more columns, not necessarily columns, but the more entities that you add to it, the greater resources it takes to retrieve it. So if we only want a list of students, if we're preparing a mailing, for example, and we only want a list of students that we're going to send like an email to or something like that, we don't need all their enrollment information. We just need the students, in that case, our query wouldn't include enrollment data. But in this case, we want to display that enrollment data, so we do include it. And what's more, we want to include the course data for each of those enrollments. So we display for each of the enrollments the course's title, the course associated with that enrollment, its title, and the grade associated with that enrollment. Again, making this more useful than just the scaffolded CRUD. I love the scaffolding stuff as much as anyone does. It's great that you don't have to manually write a lot of that code, that it does so much for you. However, that does not make for a completed application. Put things in that make it more useful. And in this case, for someone to be able to look up a student and see all the courses that they are enrolled in is something that's very useful. All right. Last thing I like to do, this was stuff that was already built in the example. The last thing I would like to do would be to look at the two rosters. And again, this is something that could be done a number of different ways. I picked a way to do it. Actually, I picked two ways to do it. I have my list of courses and a list of enrollments. Actually, it's not a list of courses, it's a single course and the enrollments associated with it. I said, give me, for that course, using the where clause, include the department and include the instructor. Could I have done the enrollments as part of it? I sure could have. In fact, what I'll try to do after I demonstrate this is I'll try rewriting this. This Linq is something that's fairly new to me too, so I don't claim to be perfect at it, and I don't claim to be an absolute expert at it. So I'm still learning better ways to do things as well. Here I pull the single course. Here I pull the list of enrollments associated with that course. When I populate the course, I populate the department and the instructors. That can be a list of instructors. I then go through and I display the course title, the department name. I loop through and display all the instructors because there can be more than one. And then I loop through the enrollments and display all the students. Probably would have been better for me to do this. Tell it that with that course, I would include all the enrollments associated with that course. And then include, because I don't want it associated with the course, I want it associated with the enrollment. So then include all the students for that enrollment. So all these includes relate to the main table that we're going after, the students. The then include combines the student in there and gives the student information. I'm going to have to rewrite this a little bit to say, I'll comment this out as well. Now I'm not pulling it from its own list. I'm pulling it from the enrollment list that is part of a course. So I just realized that as I was looking at that this is a better way to do it. Make sure it still works. Sure enough, it looks like it does. The idea again of these links is you're creating a list and you're adding to the list, maybe adding related data to the list, sorting data in the list, or maybe filtering data from the list. All right. All those have their own methods to do that. Let's look at roster 1. I have a feeling this one could have been done a lot better as well. This one, again, I do too, and I'm sure I could probably similarly combine these two to work as just one query like I did previously. I might do that for next time. I'll have to see how that works out. At any rate, notice the syntax is different. I'm doing a select and I'm picking what I want. The title from the course, the department from the department name, and instructors from the list of instructors associated with that course. Finally, I'm pulling the list of student enrollments and I'm grabbing the student's full name, putting it in a variable called students. Yeah, ignore this one. This one, if I do have time, I'll rewrite it. It works, but it is probably a slightly inefficient and slightly confusing way. So just ignore this one. The main point I wanted to illustrate with this is that you can use this other kind of syntax, but we've already seen examples of that, and here's another one. But again, this could be simplified quite a bit. All right, I will post this example. If there are no further questions, there are no questions. That's all I have for this week. I'll post this example, and probably for next week, I'll post a altered version of that the roster 1 code. All right. If you have any questions at all, please let me know.